Hello and welcome to SigmaXL video tutorials. In this video, we'll demonstrate the use of advanced design of experiments in SigmaXL, specifically Augment 2-level Factorial screening Foldover design. We will illustrate the use of an advanced 2-level Factorial screening design with the famous 7-factor, 8-run bicycle experiment, given in example 6.5 of the Box Hunter book. Statistics for Experimenters, 2nd edition. The response variable is the time it took to climb a particular hill in seconds. The runs were made in random order, but will be given here in standard order to match the book. The 7 categorical factors are seat position, up, down, dynamo, off, on, position of the handlebars, up, down, gear settings, low, medium, wearing a raincoat, on or off, had breakfast in the morning, yes, no, and tires, hard and soft. After analysis, the design will be augmented to add a foldover on a specific factor to estimate it free of aliasing. To begin, click SigmaXL, Design of Experiments, Advanced Design of Experiments, 2-level Factorial Screening, 2-level Factorial Screening Designs. Select number of categorical factors equals 7 and number of continuous factors equals 0. Enter factor names and level settings as shown. You may scroll down to enter names and level settings for factors F and G, or you can simply hit Tab while entering the factor settings and names. Enter response name as time. Uncheck randomized runs. With the default design power information, terms and model, all main effects, a message is given, power cannot be calculated when there are no degrees of freedom for error. So change design power information, terms and model to 1 main effect. This design has medium power to detect an effect size equal to 2.5 times the standard deviation. Using a 1 main effect model with error degrees of freedom equal to 6. Click OK. The Design of Experiments worksheet is produced, including the legend, design generators, aliasing of effects, and design power information. The design generators match those given in the book. Aliasing of effects to order 2 is given. When using a resolution 3 design like this, we assume that the two-way interactions are negligible relative to the main effects. Open the file BHH bicycle. This has the design worksheet populated with time values. Click SigmaXL, Design of Experiments, and under Advanced Design of Experiments, select 2-level Factorial Screening, Analyze 2-level Factorial Screening Design. Select Time as the response, and click Select All to select all available model terms. Uncheck Residual Plots, since we have 0 degrees of freedom for error. Check Main Effects Plots. Click OK. Note that since this is a saturated model, SE coefficients are computed using length pseudo-standard error. P-values are computed using Monte Carlo simulation with 10,000 replications. Seat, dynamo, and gear are significant, with p-values of less than 0.05. We could refit the model with only these 3, or run stepwise best subsets, but we will not do so here. Pareto charts for term R-square and standardized effects are given. Click on Sheet Plots to view the main effects plots. Hovering the cursor on the main effects plot for dynamo, we see that the mean time increases from 60.5 to 72.5 seconds when dynamo is on. So dynamo is adding 12 seconds to the hill climb time. The mean time increases from 55.25 to 77.75 for gear low to medium. So gear is adding 22.5 seconds to the time. These main effects can also be calculated by doubling the term coefficient values. Given that gear is the dominant factor and that the experimenter suspected that gear might interact with other factors, a single column foldover design was carried out to remove aliasing from the gear term. Click on sheet BHH Bicycle 1. Click Design of Experiments, and under Advanced Design of Experiments, select Augment 2-Level Factorial Screening, Augment Design. Select Gear and click Model Terms. Use the default setting for Design Power Report. Uncheck Randomize Folded Runs. Click OK. The new worksheet augments the original fractional factorial design with 8 new runs as a block, where the gear column is folded and all other columns are unchanged. Note that for factor D, gear, the main effect is free and clear of any aliasing with two-way interactions, and two-way interactions involving D are free and clear of other two-way interactions. However, the other main effects are still aliased with two-way interactions. Using a single column foldover design effectively produces a hybrid resolution 3 and 5 design. This design has medium power to detect an effect size equal to 2.0 times the standard deviation, using all main effects with blocks model with error degrees of freedom equal to 7. Click on sheet BHH Bicycle 2. This has the augmented design worksheet populated with time values. Click Design of Experiments, and under Advanced Design of Experiments, select Augment 2-Level Factorial Screening, Analyze Augmented Design. Select Time and click Responses Y, with Term Generator as Main Effects plus two-way interactions. Select the 7 main effects seat to tires and the 6 two-way interactions involving gear, seat gear, dynamo gear, handlebars gear, gear raincoat, gear breakfast, and gear tires. Click Model Terms. Finally, select Seat Dynamo to estimate the aliased interactions AB equals CG equals EF. Check Include Blocks. With 14 model terms, plus the constant and block term, there will be no degrees of freedom for error, so uncheck residual plots. Leave main effects and interaction plots unchecked. Click OK. Note that since this is a saturated model, SE coefficients are computed using length pseudo-standard error. Dynamo and gear are the only significant terms, and this is in agreement with Box Hunter Hunter. The large main effect for factor gear is now estimated free of aliases. Also, as required, all two-factor interactions involving gear are free of aliases, although for this particular set of data, none of these are distinguishable from noise. In this case, then the tentative conclusions from the first 8 runs appears to be borne out. The Pareto charts of term R-square and standardized effects are given. Now, we will refit the model using forward stepwise with criterion AICC. Click Recall SigmaXL dialog, or press F3. Click Advanced Options. Check Stepwise Best Subsets Regression. Select Forward Selection. Criterion AICC. Click OK. Click OK again. The stepwise model reduces to just the dynamo and gear term with a very good R-square equal to 96.7%. and R-square predicted equal to 94.9%. Scroll to the predicted response calculator. Set goal to minimize. The default reference values of dynamo equal to off and gear equal to low are the minimum time settings, but we will run optimize anyway, since it is rarely the case that the default settings give an optimum. Click Optimize. Click Yes. The predicted hail time climb is approximately 50 seconds, with a confidence interval of 47.3 to 52.4 seconds. This concludes the SigmaXL tutorial video for Augment 2-level Factorial Foldover design. For more videos, visit www.sigmaxl.com or join us on YouTube. Thank you for watching.